So first you need to know the operation of a computer. Yes, here processor, this is the processor, it fetches the information, that is data or program. When I say program means what? It is a set of instructions. So I'll take a simple example now. Here you can see the program. Here simple program to add two numbers, that is 25 and 15. So here you can see this is how many instructions are there? Three instructions are there. Int a is equal to 25 semicolon, int b is equal to 15 semicolon, c is equal to a plus b semicolon. This is just for explanatory purpose. Okay, just for explanation purpose. I have taken these three instructions. So I call this as a program. Fine. And what is data here? Data is 25 and 15 are the data. Data is what? It is a operand. Data is also called as operand. Okay, so data means it is a number or coded characters. So when I say coded characters, if you have watched my previous video, that is conversion from binary to hexadecimal, decimal to binary, like that. So this is what what processor does. First, whenever you this is what input devices. What are input devices? Keyboard, mouse, joystick, scanner, webcam, web camera, and microphone, right? So let me take an example of keyboard. Whenever a key is pressed from the keyboard, either alphabet or numbers, so that alphabet or numbers will be converted to ASCII value. That is, ASCII means what? ASCII. ASCII stands for American Standard Code for Information and Interchange. Whenever a key is pressed from the keyboard, ASCII value of the pressed key will be stored in the buffer register. Buffer register is a memory storage element. Okay, memory storage element. It stores the data. Okay, it stores the whatever the characters you enter will be converted to ASCII value, and that it gets stored in the buffer register. Why are we using buffer register? Why are we using these buffer registers? Are placed in the input as well as output devices. Why are we using buffer register? To synchronize between processor and input devices. Why do we have to synchronize? Because input devices and output devices are slower compared to processor and memory. So we need to sync both, right? Yes. So that is what synchronization means. Since input and output devices are slower than that of processor and memory, it needs to be synchronized, right? That is the reason we make use of buffer registers. Okay, so whatever the characters you enter will be stored in the buffer register. Now then buffer, what processor does? Processor fetches those instructions, whatever the program you type, that whatever the instructions or and data. Like for example, these are the instructions, right? These this is what high level language. This is high level language. This will be converted to machine language. Okay, that is object program. This is the source program. Int a is what? This is source program, and a compiler converts this source program to object program, that is machine level language. Okay, that is machine language means object program. It has ones and zeros, right? So now we need to have some scheme here, that is ASCII, and we have one more scheme called EBCDIC, that is embedded binary coded decimal in what is that? Interchange code. Okay, there are two schemes. One is ASCII, that is American Standard Code for Information Interchange, and second one is EBCIC. Okay, that is EBCDIC, that is E stand for extended binary coded decimal interchange code. Okay, so two schemes now, ASCII and EBCDIC. Okay, so now later we'll discuss about that in detail. So now what will happen? Now processor fetches that data from the buffer registers. It's already now it has the data, right? That is the program as well as the data. So processor fetches that data and converts it into what? Binary, that is a human machine language, that's object program, and stores it in the memory. Okay, it will not execute the program, it will not directly execute the program. First processor fetches these instructions, these three instructions, and stores it in the memory, main memory. This is random access memory. Okay, so now what will happen? How will processor fetch the data? Can processor directly fetch the instructions from the memory? No. First each and every instruction will be given an address. Okay, so these instructions are stored in the memory box. Okay, so now processor should know the address of each and every instruction. Okay, so each and every instructions are given an address or location, just like you, if we have address or address, home address, then I can come and meet you. So, right, each and every person will have some address, right? So that is what each and every instruction is given an address. And here we have data. Data is also have address. Data will also have some address. Each and every data is given some address to fetch the data. Now process's job is to fetch the address by sending the by fetch these instruction by sending the address of each instruction. And what processor does, it fetches the first instruction int a is equal to 25, and it keeps it in the cache memory. Again processor sends the address of int b is equal to 15 and fetches this instruction and keeps it in the cache memory. And again it fetches c is equal to a plus b, right, and by sending the address and keeps it in the cache memory. So once it keeps it in the cache, why are we using cache memory? Because cache memory is the fastest unit. Okay, so why do we have to use for this one cache memory? Because to what is that, to increase the performance of the computer. Okay, to increase the performance of a computer, again processor has to go to main memory in order to fetch the data. It takes a lot of time, right? That is the reason this processor and cache memory are fabricated on a single chip. Processor as well as cache memory are fabricated on a single chip. Now processor fetches, need not go to main memory, it need not to go to main memory to fetch the instruction each and every time. Okay, all the instructions and data. Again, how will the data be fetched from the main memory? Again, it has to send the address. Processor has to send the address of each data to fetch 25 and 15. And will this 25 and 15 be stored in the memory? No. First 25 will be this is a decimal number. When you go to market, if you want to purchase some items, when you say 25 rupees, so but computer converts that 25 rupees, that is decimal number, human language, again it converts it into ASCII code. Yeah, so how do we convert decimal to a hexadecimal number, that is binary or a hexadecimal number? Please watch my previous video, then you'll understand. Okay, so this is how it converts what decimal number to hexadecimal and stores it in the memory. Okay, so hexadecimal number. Now memory, in main memory we can store only binaries, that is hexadecimal values. Okay, hexadecimal means what is a coded value. Okay, so means what, 4 bits will be grouped. Okay, next, once it is stored in the memory, now again, now instructions as well as data both are in the main memory. Now processor's job is to fetch the instructions. One, now a processor has fetched the instruction. Now processor will fetch the data also, that is 25 and 15, and keeps it in the cache memory. Now the instructions, all three instructions as well as data are present in the cache memory. Now processor will start executing the operation. How will it execute the operation? With the help of arithmetic and logic unit. So right, arithmetic and logic unit. Now by using this arithmetic and logic unit, it performs addition operation. Okay, so once it performs the addition operation, again you either it can be stored in the memory. How will it store the memory? So this entire operation will be controlled by the control unit. We have control unit that performs the entire operation. Processor cannot directly store the instructions and data into the memory. Okay, so that control unit has to give permission. If control unit sends read signal, then only it can store these three instruction into the memory. And also if processor wants to write some data, okay, write some data, then it has to, write means what, write means store, read means fetch the data from the memory, write means store the data into the memory, like that. Okay, so processor has to take permission of from control unit. That is, control unit is what, it controls the entire operation of the computer. So once everything is done, what ALU does, it will, what is that, now ALU performs the operation, and the final result will be sent to the output world. What is output devices? Web camera, speaker, microphone, printer, headphone, monitor, right? These are what? Output devices, right? Now this entire operation is controlled by control unit. Control unit's job is what? It generates a timing signal. Why will it generate timing signal? For example, say you are the what, input and output devices, I am the processor. Okay, so and you are controlled by your parents. Control unit is they'll, for example, your parents ask you to go to market to fetch what is it, to get some vegetables. So they'll use 10 minutes time. So within that time we'll have to go get the vegetables. So that is what control, that is the job of control unit. It generates timing signal to the processor, within which it has to go read the data or write the data into the memory. read the data from the memory or write data into the memory. So control unit's job is to generate timing signal. Okay, by generating timing signal, it controls the entire operation. Okay, so now let us see what is a computer or digital computer. A computer is a fast electronic calculating machine that accepts digitized information, input information, that's ones and zeros, processes it according to a list of internally stored instructions and produces the resulting output information, right? And then computer types. What are computer types? Personal computer, desktop computer, portable notebook computers, workstations, enterprise systems and servers, supercomputers, enterprise systems, or mainframes. These computers have different computational power and configurations. Based on the requirement, end user can opt any of these systems. Basic functional units of a computer. A computer consists of 5 functionally independent main parts: input, memory, arithmetic and logic unit, output unit, and control units. So this is the diagram, basic functional units of a computer. This is the diagram, block diagram. Basic functional units of a computer again. So here the input unit accepts coded information, that is ASCII value, ASCII or EBCD IC, that is extended binary coded decimal interchange code, right? ASCII means American Standard Code for Information and Interchange. That is the coded information from human operators, from electromechanical devices such as keyboards, or from other computer or digital communication lines. So the information received is either stored in the computer's memory for later reference or immediately used by the arithmetic and logic circuitry to perform desired operation. When I say desired operation, that's addition, subtraction, multiplication, and operation, or not. That's logical operation, right? So next, a program stored in the memory determines the processing steps. Finally, the results are sent back to the outside world through the output unit. All these actions are coordinated by the control unit. So instructions or machine instructions. Instructions or machine instructions means that's what we have seen, right? Int a is equal 25. That is those are instructions. Are explicit commands. Those are the commands that govern the transfer of information within a computer as well as between the computer and its IO devices. So this is IO devices. Let me change this to IO devices and its IO devices. Fine. So next, specify the and it specify and in these instructions specify the arithmetic and logic operations to be performed. That's what add c is equal to a plus b. That is what addition operation, right? Like that. So what is a program and memory? A list of instructions that performs a task is called program. That's we have seen 3 instructions, right? That is what list of instructions that perform a task. It's addition operation task, right? Program is called a program, and internal storage is called computer memory. Where do you store that program? In the memory. And where do you store the data that are used in the program? In the memory. So that is internal storage. Usually the program is stored in the memory. The processor then fetches the instructions that make up the program from the memory one after another and performs the desired operation. So first, before the processor is being performing any operation, that program must be stored in the memory, computer memory. The computer is completely controlled by the stored program except for the possible external interruption by an operator or by IO devices. Data or operands, that is 25 and 15, whatever that values you have used, right? That is what data, okay, or operands, one and the same. Data are numbers and encoded characters. What is SQLF capital A? It is 41H or 65D decimal. 41H stands for hexadecimal, 65D stands for decimal number. Data are numbers and encoded characters, that is encoded characters like by ones and zeros, that are used as operands by the instructions. When I say encoded, ASCII or EBCDIC, right? EBCDIC. And then within this definition of data, an entire program, that is list of instructions, may be considered as data if it is to be processed by another program. Here another program is what? Compiler. If you give what is the input to the compiler? Source program, that is high level language, English language. So we had 3 instructions that will be converted to machine language, right? So example of this is the task of compiling a high level language, that or source program into a list of machine instructions constituting a machine language program called the object program. Here the source program is the input data to the compiler program. It's a compiler program, right? Compiler is a program, okay, which translates the source program into machine language program. Machine language means what? Object program, okay. So what does the object program contains? It is ones and zeros, like that, the computer machine language, okay. How is a number, character, or an instruction encoded? Information handled by a computer must be encoded in a suitable format. Digital circuits have only two stable states, on and off. Each number, character, or instruction is encoded as string of binary digits called bits, each having one of two possible values, 0 or 1. Numbers are represented in binary notation. Yes. The binary coded decimal format is employed in which each decimal digit means what? 0, 1, 2, 3, so on till 9, 0 to 9. Okay, is encoded by 4 bits, that is 0 to 9, and this is what? This is the range of BCD 0000 to 1001. Okay, and so this is how we convert 1D is equal to 0001, 2D is equal to 0010, so on. Okay, and so here be careful, 15D, how do you write 15D? So take first digit 1 and convert it to 0001, and take this 5, convert it to 0101. Now answer this 25H, what is the answer? Convert this hexadecimal to BCD. Okay, and be careful while converting from hexadecimal to BCD, because you will have to convert to hexadecimal to decimal first, and from decimal to BCD. Here also same thing, hexadecimal to decimal, and decimal to BCD. You already know 15D is what? This is 15D. So next 25D, you don't have to convert to decimal because it's already decimal number. D represents decimal, H represents hexadecimal. So how is the number? Okay, this is a continued part. Okay, all alphanumeric characters, that is alphabets and numbers. Numeric means numbers. So characters are also expressed in terms of binary codes. Several coding schemes have been developed. That is what we have discussed, right? ASCII, American Standard Code for Information Interchange, and in which each character is represented as a 7-bit code. How many bits? 7-bit for ASCII. And for EBCDIC, that is Extended Binary Coded Decimal Interchange Code, in which 8 bits are used to denote a character. For example, character A, capital A, whenever a key is pressed from the keyboard, capital A, okay, then so Abhi, if first letter is what? Capital A, that's what is the ASCII value of capital A, 41H, and convert this to binary. And how do you convert it to binary to decimal? Please watch my previous video, so then you'll understand this one. Okay, so next capital B, 42H, converted to binary, 6060. So all are same, equal. Okay, capital C, 43H, and character is this lowercase a, 61H and 97D. This ASCII value of lowercase a is 61H or 97D. Character B is what? That please comment below. And this is what? Input device. Okay, this is input devices: keyboard, mouse, joystick, scanner, webcam, and microphone. So what is input device? Input unit. Computer accepts coded information through input units which read the data. The most well-known input device is keyboard. Whenever a key is pressed, the corresponding letter or digit is automatically translated into its corresponding binary code and transmitted over a cable to either the memory or the processor. Yes, how will it store? Now the whatever the key you press from the keyboard will be stored in the buffer register. That is very important. Okay, that gets stored in buffer register. From buffer register, it goes to memory and processor through a cable, over a cable. So next examples: keyboard, mouse, microphone, joystick, trackballs. So memory unit. The function of the memory unit is to store programs and data. There are two classes of storage called primary storage and secondary storage. Primary storage means random access memory. Secondary storage is what? Hard disk drive, CD, ROM, like that, CD, DVD and all. So primary storage is fast memory, that is RAM is fast memory that operates at electronic speed. Program must be stored in the memory while they are being executed. It must be stored in the memory, obviously. The memory contains a large number of semiconductor storage cells. This entire memory unit, whatever that RAM, is made up of semiconductor storage cells. Each and every semiconductor storage cell can store only one bit of information. If the computer is of 16-bit, 64-bit, then we require 64-bit semiconductor storage cells, like that, because each bit is what? It can store only one bit of information. That's why. So these cells are processed in groups of fixed size called words. An address is associated with each word location to access any word in the memory. So that's what each and every instruction and each and every what is that data is given an address, right? So in order to access it from the memory. So that is our address is also called as memory location, one and the same. Address or memory location, one and the same. So this is the word now. So for example, I'll press 6536. 6536 is a decimal number. And what processor does? Processor converts it that decimal number to hexadecimal and stores it into the memory. That is what this is the memory now. This block is what? Entire block is memory block. and this is the data 6536, and it's converted the hexadecimal equivalent of 6536. I don't know whether it exactly it is 6536. I just take an example. Okay, so now what is the address of this 12A5H? So if processor wants to read this 4161H, it has to send this address 12A5, then only it can fetch this particular data. This is data word. Okay, so word length may vary from 16-bit to 64-bit. It's not a fixed number. It depends on the, depending on the machine, it may vary. Okay, word length may vary. Here you can see how many bits. 4 bits, 4 bits, 4 bit, 4 bit, 4 fours are 16 bits. So 16 bits are required to represent this 4161H. So next, addresses are numbers that identify successive locations. So that's what addresses are: numbers. 1 to A5 is a number that this is a successive memory location, right? Successive locations. So a given word is accessed. A given word is accessed by specifying its address and issuing the control command that starts the storage. That is write. Storage means write signal, and retrieval process means read from the memory. Write to the memory and read from the memory. So RAM, random access memory. Programs must reside in the memory during execution, and data can be written into the memory or read out under the control of the processor. We should be able to access any word location in the memory as quickly as possible. Memory in which any location can be reached in a short and fixed amount of time after specifying its address is called random access memory. Okay. So that's what we need to processor has, instead of processor has to go to main memory in order to fetch each and every instruction. It takes a lot of time, right? That is the reason we what is that we make use of random access memory. So processor need not go to main memory to fetch the data each and every time. So that is why. So next, now this is the random access memory. These are storage, that is semiconductor storage cells. Each and every ICs has semiconductor storage cells. Fine. And processor, this is the processor, image of processor. So memory unit, so now you can see this is the address of the memory, and this is word 4161H. So memory access time required to access one word. This is the one word, this is one word. Okay, 16 bits. So how many bits? 16 bits, one word. Time required to access one word is called memory access time. Means what? If processor takes 1 second to access this particular word, then it's what? Memory access time is what? 1 second. So however, it is not 1 second. It typically ranges from a few nanoseconds. Means what? Fraction of a second. Nanosecond means 10 raised to -9 to about 100 nanoseconds for modern RAM. Means nowadays 100 nanoseconds means only within a fraction of a second. That is 10 raised to -9 means 0.00 zeros followed by 1. Okay, so within a fraction of a second, that data can be fetched from the memory. Processor can fetch the data. Caches means what is cache and what is the use of cache. The small and fast RAM units are called as caches, and then these caches are tightly coupled with the processor and are often contained on the same integrated chip to achieve high performance. That's whatever the frequently used data, frequently used instructions are stored in the cache memory. Then so that processor need not go to main memory to fetch the data. Okay, that is the reason we use cache memory. So main memory, the largest and slowest unit is referred to as main memory. Okay, so it's the slowest unit because it takes a lot of time for the processor to go fetch the data from the main memory. So secondary storage, although primary storage is essential, it tends to be expensive. Primary storage or random access memory, right? It is very expensive, right? That is the reason we go for secondary storage. Is used when large amounts of data and many programs have to be stored. For example, videos, images of what is that 1 GB video, 2 GB videos, like we cannot store it in RAM. That is the reason we make use of secondary storage. Why can't we store it in primary storage permanently? Because they are very expensive, right? So secondary storage devices are magnetic disk, magnetic tapes, optical discs, that is CD-ROMs, right? So this is the image of magnetic disk, and this is the image of magnetic tapes. I think you have seen this, right? So optical disc, this is what? CD, DVD, ROMs. Okay, and read only memory, that is CD ROMs means read only memory. Next, ALU, most computers operations are executed in arithmetic and logic unit of the processor. Yes, consider an example. Suppose you want to add two numbers that are located in the memory. They are brought into the processor. First, see, now they are in the memory, right? They are brought into the processor, and the actual addition is carried out by the ALU. The sum may then be stored in the memory or retained in the processor itself for immediate use. Any other arithmetic logic operation, for example, multiplication, division, or comparison of numbers, is initiated by bringing the required operands into the processor where the operation is performed by the ALU. So whatever, as for example, if you want to perform addition operation, those instructions and data should be brought to the processor first. Processor has to fetch the data and instructions from the memory and keeps it in the cache memory, and then it will ALU start executing the addition operation like that. So next, registers. When operands are brought into the processor, they are stored in high-speed storage elements called registers, right? So means what? Where are these present? These registers are present in the processor itself. So whenever processor fetches the instructions and data, and that data will be stored into the register. The data gets stored into the register. That is processor register. Processor register means it's the storage elements. Okay, high speed storage elements. Each register can store one word of data. Again, as I said, word length may vary from 16 bits to 32 bit, 64 bit, right? Each register can store one word of data, depending on the machine. Okay, so which is faster, cache or register? Registers are faster than cache unit. Okay, access time to registers are somewhat faster than access time to fastest cache unit in the memory hierarchy. The control and arithmetic and logic unit are many times faster. So now compared to other units, control unit and arithmetic logic unit are many times faster than other devices connected to a computer. This enables a single processor to control a number of external devices such as keyboards, display, magnetic disk, optical disk, and sensors and mechanical controllers. Now output unit, these are the output units: web camera, speakers, microphone, monitor, printer, headphone, right? Output unit, function of output unit is to send processed results to the outside world. Examples: printer, speaker. Printer is a tremendous speed for a mechanical device, but it is still very slow compared to the electronic speed of the processor unit. Okay. Graphic display provide both an input as well as output function. Control unit. So the memory and arithmetic and logic and input output unit store and process information and perform input and output operation, right? That is addition, subtraction, so on and so on, right? So the operation of these units, that is all the input, output, and arithmetic and logic, processor and memory, must be coordinated in some way. This is the task of control unit. It's just like your parents, as I said. Okay, it generates timing signals, right? Control unit generates timing signals. The control unit is effectively the nerves center that sends control signals to other units and senses their states. It keeps checking their states, whether it is busy or not, like that. So control circuits or control unit generate these timing signals that determine when a given action is to take place. Okay, that's what, as I said, your parents are control units. They'll ask you to go to market, get vegetables. They'll give only 10 minutes time. Within that time, we'll have to go we'll have to go get the vegetables, like that. So summarize the operation. Okay, and let us summarize the entire operation now. So a processor fetches information, data, or program. Information means data, that is operands. Data is nothing but operand. Okay, or program means set of instructions from the input devices. And each and every input devices and output device will have buffer registers, right? And keeps it in the memory. Once they are stored into the memory, again processor fetches the data. Processor fetches the instructions and data from the memory. First, processor will store that instruction and data into the memory. Again, it will fetch the program and data from the memory. How will it fetch the data? With the help of by sending the address of that instruction and address of the data. It fetches the instruction and data and keeps it in the cache memory, right? And again, what will happen? That ALU performs the addition operation, subtraction, multiplication, and so on, logical operation, and or XOR and all, and stores the and sends the final result to the output world. What is that output devices? Output unit: printer, microphone, webcam, headphone, print. Okay, these are what? Speakers. These are output devices. This entire operation is controlled by the control unit of a computer. Yes, hope it is clear now. If you have any doubt, please comment below. Thank you so much for watching.